Hello and welcome to the Quantum Learning Corner, your one-stop source for all things intriguing and scientific. We're thrilled to have you join us on this exciting journey to the edge of human knowledge. If you're new here, make sure to hit the subscribe button and ring that bell so you never miss a moment of discovery. For our returning subscribers, thank you for your continued support and curiosity. Don't forget to like, comment, and share our videos. Remember, knowledge is power, and that power increases when shared. So, let's dive in, shall we? Today we're going to delve into the mind-bending world of quantum physics. It's going to be a wild ride, so buckle up and let's get started. Have you ever wondered why the smallest particles in the universe behave so differently than everything we see in our everyday lives? Welcome to the peculiar world of quantum physics, a realm where the laws of nature as we know them take a back seat. It's a place where particles can exist in multiple states at once, thanks to a concept known as superposition. It's a domain where the phenomenon of quantum entanglement allows particles to be linked no matter how far apart they are. And then there's the wave-particle duality, where particles can behave like both particles and waves. It's like your favorite superhero with a dual identity. Quantum physics is not just a quirky sideshow, it's a key player, underpinning technologies that drive our modern world from lasers to MRI scanners. So isn't it fascinating how these tiny particles seem to defy all rules we're familiar with? But wait, there's more to the story. Have you heard about Heisenberg's uncertainty principle? It's another bizarre yet fundamental concept in quantum physics. This principle, named after the German physicist Werner Heisenberg, tells us something very counterintuitive about the nature of particles at the quantum level. In our everyday world, we can measure both the speed and position of, say, a car quite precisely. But in the quantum world, things get a bit weird. According to Heisenberg's uncertainty principle, the more precisely we measure one property of a quantum particle, like its position, the less precisely we can know about its other property, like its momentum, and vice versa. Let's take an electron, for example. If we pin down its position very precisely, its speed, or more accurately, its momentum, becomes uncertain. It could be moving slowly or it could be whizzing around at high speed. We just can't tell. And here's the kicker. This is not due to any limitations in our measurement tools or techniques. It's a fundamental aspect of quantum reality. This inherent uncertainty is what makes quantum physics so different from the classical physics we're used to. Imagine not being able to know both your speed and location at the same time. Strange, isn't it? But that's quantum physics for you. Now let's dive into something even more mind-boggling. Quantum entanglement, or as Einstein famously called it, spooky action at a distance. Quantum entanglement. The term itself is enough to send shivers down the spine of physicists and laymen alike. But what exactly is it? Simply put, it's a unique phenomenon where two particles become mysteriously linked or entangled. This connection is so profound that the state of one particle instantly influences the state of the other, regardless of the distance between them. This could be from one end of a room to the other or one end of the universe to the other. The spooky part? This instantaneous interaction seems to defy the very fabric of space and time, seemingly breaking the speed of light, a universal constant. Einstein himself was so puzzled by it that he referred to it as spooky action at a distance. But beyond the realm of theoretical physics, quantum entanglement has some very real-world applications. In the field of quantum computing, for instance, entangled particles can be used to perform computations at speeds far beyond what conventional computers can achieve. And then there's quantum teleportation, an exciting field that explores the potential of transmitting information instantaneously across vast distances. While we're still far from beaming humans Star Trek style, the principles behind this concept could revolutionize communication technology as we know it. Quantum entanglement, a phenomenon so strange yet so integral to the future of technology. So what does all this mean for us and our understanding of the universe? Well, quantum physics in all its peculiar glory challenges our conventional wisdom and everyday intuition. It tells us that reality on a subatomic level isn't as straightforward as it seems. Particles can exist in multiple places at once, teleport through barriers, and even impact each other from light years away. Yes, it sounds like the plot of a science fiction novel, but it's the reality that quantum physics presents us with. Now, this isn't just mind-bending trivia. It's also the foundation of many technologies that we use today, from lasers and semiconductors to MRI scanners. And it's paving the way for future technologies like quantum computers that could revolutionize everything from cryptography to climate modeling. But perhaps most importantly, quantum physics expands our understanding of the universe. It reminds us that there are realms of reality far beyond our common sense waiting to be explored. Quantum physics, a realm where reality surpasses the limits of our imagination. The universe indeed has its mysteries, doesn't it?